NASA's Juno spacecraft captured this view of a chaotic, stormy area on Jupiter's northern hemisphere. Jupiter has no solid surface in the same way the Earth does, and data collected by Juno indicate that some of the giant planet's winds run deeper and last longer than similar atmospheric processes on Earth. At the time this image was taken, the spacecraft was about 14,600 miles from the top of Jupiter's clouds at a latitude of about 69 degrees north. This view shows several storms in Jupiter's southern hemisphere. Some of these storms, including the Great Red Spot at upper left, have been churning in the planet's atmosphere for many years. When Juno obtained this view of Jupiter, the smaller oval-shaped feature at the center of the image was brand new. The new feature, which is called Clyde Spot, was not visible in images captured just hours earlier. The feature also appeared bright when seen through filters sensitive to wavelengths of light where methane gas in Jupiter's atmosphere has strong absorption. Clyde Spot is a plume of cloud material erupting above the upper cloud layers of the Jovian atmosphere. These powerful convective outbreaks occasionally erupt in the latitude band known as the South Temperate Belt. At the time the image was taken, Juno was between 28,000 miles and 59,000 miles from the planet's cloud tops at latitudes of between about 48 degrees and 67 degrees south. This view of Jupiter's south pole shows oval storms dot the planet's cloudscape. Approaching the pole, the organized turbulence of Jupiter's belts and zones transitions into clusters of unorganized filamentary structures, streams of air that resemble giant tangled strings. The image was taken from an altitude of about 32,400 miles above the planet's cloud tops. Jupiter's north pole has 8 storms swirling around its center. Scientists aren't sure why these storms are laid out in such a precise geometrical manner, but they seem to be stable fixtures in Jupiter's atmosphere and not fleeting weather patterns. This image shows Jupiter's south pole as seen from an altitude of 32,000 miles in daylight. The oval features are cyclones up to 600 miles in diameter. A stunningly detailed look of a cyclonic storm in Jupiter's atmosphere is seen in this view. Juno observed this vortex in a region of Jupiter called the North-North-North-North Temperate Belt, one of the gas giant's many persistent cloud bands. These bands are formed by the prevailing winds at different latitudes. The vortex seen here is roughly 1200 miles wide. Jupiter is composed mostly of hydrogen and helium, but some of the color in its clouds may come from plumes of sulfur and phosphorus containing gases rising from the planet's warmer interior. At the time this image was taken, the spacecraft was about 5,300 miles from Jupiter's cloud tops above a latitude of about 49 degrees. Jupiter's volcanically active moon Io casts its shadow on the planet in this image. As with solar eclipses on the Earth, within the dark circle racing across Jupiter's cloud tops, one would witness a full solar eclipse as Io passes in front of the Sun. Such events occur frequently on Jupiter because it is a large planet with many moons. In addition, unlike most other planets in our solar system, Jupiter's axis is not highly tilted relative to its orbit, so the Sun never strays far from Jupiter's equatorial plane. This means Jupiter's moons regularly cast their shadows on the planet throughout its year. Juno's close proximity to Jupiter provides an exceptional fish-eye view showing a small fraction near the planet's equator. The shadow is about 2,200 miles wide, approximately the same width as Io, but appears much larger relative to Jupiter. A little larger than Earth's moon, Io is perhaps most famous for its many active volcanoes, often caught lofting fountains of ejecta well above its thin atmosphere. This view shows the stunning complexity in Jupiter's atmosphere. What we're looking at here are Jupiter's clouds from a distance about equal to the diameter of Earth. The vivid colors you see in thick bands across Jupiter may be plumes of sulfur and phosphorus containing gases rising from the planet's warmer interior. Like on Earth, Jupiter's atmosphere and cloud formations encircle the planet in great jet streams. These are elaborate atmospheric jets in Jupiter's northern mid-latitude region. The detailed image here reveals a complex topography in Jupiter's cloud tops. If you look closely, relatively small, bright pop-up clouds which rise above the surrounding features stand out at the tops and edges of the swirling patterns, while the darker areas nearby reveal greater depth. At the time this image was taken, the Juno spacecraft was about 5,375 miles from Jupiter's cloud tops at a latitude of about 50 degrees north. The spacecraft was traveling about 127,000 miles per hour relative to the planet at the time. Juno spacecraft captured this image when it flew just 5,600 miles above Jupiter's most recognizable feature, the Great Red Spot. The storm has raged for 350 years, and this image is the closest look ever at the spot, which has actually been shrinking over the past few decades. This image comes from NASA's James Webb Telescope, which shows auroras extend to high altitudes above both the northern and southern poles of Jupiter. The image comes from the observatory's near-infrared camera, which has three specialized infrared filters that showcase details of the planet. Since infrared light is invisible to human eye, the light has been mapped onto the visible spectrum. Generally, the longest wavelengths appear redder and the shortest wavelengths are shown as more blue. In this image, auroras shine in a filter that is mapped to redder colors, which also highlights light reflected from lower clouds and upper hazes. A different filter mapped to yellows and greens shows hazes swirling around the northern and southern poles, and a third filter mapped to blues showcases light that is reflected from a deeper main cloud. The Great Red Spot, a storm so big it could swallow Earth, appears white in these views, as do other clouds, because they are reflecting a lot of sunlight. The Great Red Spot also has high altitude hazes, as does the equatorial region. The numerous bright white spots and streaks are likely very high altitude cloud tops of condensed convective storms. By contrast, dark ribbons north of the equatorial region have little cloud cover. Colorful, intricate patterns in a jet stream region of Jupiter's northern hemisphere, known as Jet N3, can be seen in this view. Jupiter's cloud tops do not form a simple flat surface. Data from Juno spacecraft helped scientists discover that the swirling bands in the atmosphere extend deep into the planet to a depth of about 1900 miles. At center right, a patch of bright, high-altitude pop-up clouds rises above the surrounding atmosphere. At the time the image was taken, the spacecraft was about 6,000 miles from the tops of the clouds at a latitude of 39 degrees north. Oval BA, the large muddy circle of clouds near the upper left of this picture, is a storm approximately the same size as Earth. The bright storm below and to the right of Oval BA is one of Jupiter's string of pearls, massive counterclockwise rotating storms that appear as white ovals in the gas giant's southern hemisphere. Juno's elliptical orbit around Jupiter is evolving gradually as the closest approach point moves farther north on each pass. Shorter, closer views in the north are accompanied by a longer duration, more distant perspective for viewing the southern hemisphere. These changes in perspective give us ever new views of this beautiful giant and its huge storms. This image captures a high-altitude cloud formation surrounded by swirling patterns in the atmosphere of Jupiter's north-north temperate belt region. The north-north temperate belt is one of Jupiter's many colorful swirling cloud bands. Scientists have wondered for decades how deep these bands extend. Gravity measurements collected by Juno during its close flybys of the planet have now provided an answer. Juno discovered that these bands of flowing atmosphere actually penetrate deep into the planet to a depth of about 1900 miles. At the time this image was taken, Juno was about 3900 miles from the planet's cloud tops above a latitude of 36 degrees. This wide field view of Jupiter was taken by James Webb Telescope, which shows Jupiter with its faint rings, which are 1,000,000 times fainter than the planet. Two of Jupiter's tiny moons called Amalthea and Adrastea are also visible in the image. The fuzzy spots in the lower background are likely galaxies photobombing this Jovian view. Some incredible images of Jupiter resembling abstract watercolor paintings have emerged from NASA through its Juno mission. This image shows two large rotating storms on Jupiter. Small bright clouds dot Jupiter's entire tropical zone in this image acquired by Juno spacecraft from an altitude of 7,990 miles. Although the bright clouds appear tiny in this vast Jovian cloudscape, they actually are cloud towers roughly 30 miles wide and 30 miles high that cast shadows on the clouds below. On Jupiter, clouds this high are almost certainly composed of water or ammonia ice, and they may be sources of lightning. This is the first time so many cloud towers have been visible, possibly because the late afternoon lightning is particularly good at this geometry. Juno's spacecraft captured this image when the spacecraft was only 11,747 miles from the tops of Jupiter's clouds. That's roughly as far as the distance between New York City and Perth, Australia. The image shows a cloud system in the northern hemisphere. This is what Juno's spacecraft sees as it completes its orbit from pole to pole, which takes about 2 hours. Jupiter is made up of the same basic ingredients as the Sun, mainly hydrogen and helium. With 69 moons, Jupiter is kind of like the solar system in miniature. Scientists are hoping a close-up investigation of its surface can reveal some history of the origin of our solar system. Studying Jupiter can also help us understand the cosmos better. A monstrous storm in Jupiter's northern hemisphere is seen in this view.